Thanks for joining us at Code Fair. Our application is called MSET, and I am Ruthie Urbanovich.
Gabby Mendez.
Jesse Edelman.
And Michael Evans.
Whether you are taking a specific medication or just exploring treatment options, monitoring your progression in a meaningful way can be challenging. Enter MSET, the medication side effect tracker, which allows users to take control of their medical treatment by tracking various medications and supplements and their associated side effects in order to cultivate a more complete picture of how their treatment is impacting their well-being and provide their doctor with holistic feedback in order to shape their treatment plan.
Now we'll dive into the app itself. After registering via Google OAuth, we land on the dashboard where we'll see the default interface without any medications or symptoms having been logged yet. We can log a new medication in the lower left-hand corner, and here we can search for Xanax. The results from the search bar are populated by the response of a Faraday call to our Sinatra microservice, which makes a GET request to a medication search endpoint via the open FDA API. And when we add the medication, we're redirected back to the dashboard where you can see that Xanax has been added to our profile info on the left. On the back end, as you add new medication, another GET request is made to access a list of adverse reactions and side effects associated with the medication. Here on the medication show page, you can see the medication's brand name, product NDC code, and all the potential side effects that we received from the API call. Any medications that we add, we use the potential side effects from them to populate the symptom search results when we are ready to log a symptom. Here, if we search for a keyword, we use the Jero-Winkler string distance, and any phrase or word that is a 70% or greater match to whatever we've entered is returned. We can select the date and add any additional notes. And when we hit save, we notice that we're redirected back to the dashboard where we'll see the symptom log has been saved and is displayed in our recent logs. Over time, the user can continue logging and tracking symptoms, and here we can see their 10 most recent logs displayed on the dashboard. If we'd like to see our full symptom log history, we can navigate to the symptom logs index page. In a future iteration of this app, we'd like to allow a user to filter logs on the index page by date and symptom in order to more intuitively identify patterns over time.
Built with a service-oriented architecture, MSET is comprised of two applications, an API microservice in Sinatra and a user-facing Rails app. The Sinatra app is responsible for making external calls via the Faraday gem to two open FDA API endpoints via GET requests, which are then exposed for a Rails app to consume. In addition to consuming those two endpoints from Sinatra, the user-facing Rails app parses through those responses and formats the data to display to our users or save in the database. For our database, we considered a number of different approaches to the association between symptoms, medications, and users, and landed on associating symptoms with medications in order to populate a list of potential symptoms that a user might experience given the medications they've added to their list. Additionally, if a user wishes to log a symptom that wasn't already available, the app will add the new system into the database when they type it in.
For optimization, we chose to index the unique user ID from the Google OAuth process, as well as the product NDC from the Open FDA API. Action and fragment caching were also utilized.
As for testing, in addition to coverage of several SAD paths related to user input, our tests covered edge cases, like when a medication added to a user's list does not have any side effects. And we also implemented WebMock and VCR to mock responses for API calls to speed up testing. Our test suite yielded 100% coverage via SimpleCov. As for challenges and wins, with our team working quite well together, we had several wins. Intentional project management, consistent story grooming, and active communication kept us up to date on what we were each working on and how we could help each other out. It also allowed us the time and space to not only achieve our MVP, but to execute a handful of extensions as well.
Some of the challenges we faced, whenever this project began, we had not yet identified an API that would provide us with the medication and side effect information that we wanted. During our search, we found two APIs that had more than enough information and great documentation, but the purchase of an API key was required. In the end, we chose to use the Open FDA API. Although we were able to extract the information we needed from it, the response format led to another significant hurdle. Inside the JSON response, the side effects were embedded within a table built with raw HTML, and we had to use Nokogiri to parse through it.
Other challenges included implementing a presentable front end, given that we are back-end students after all. One of the user experience decisions we made was to switch from using a dropdown for users to select from available symptoms when logging them to using a search bar instead that populated a new search results page. For future iterations of this app, we'd like to implement the option for a user to log multiple symptoms at one time, a filtering option for their symptom log history, the ability to receive reminders to take medications at specific times, and then log when a medication was taken. We envision the ability to tie when a user took a medication to their symptom log patterns to be the ultimate value prop for this app. The end goal for future iterations is to make it easier for a user to holistically track the effect of various treatments and identify any significant patterns therein.
Thanks for tuning in to learn about MSET.